Our final function for this evening is the family of radical functions. Probably the most famous example is the square root function. This graph is exactly a parabola that's been put on its side. The reason for that is that square root of x is the inverse function to y equals x squared, and inverse functions always have a graph that is flipped over and laid on its side. It's important to notice that the square root function is set up so that it always gives a number which is greater than or equal to 0. This is actually worth repeating. The square root of x is always a number that is positive or possibly 0. When you write radical x, that will never be describing a negative number. That rule will save you so much time in algebraic manipulations. It is a lifesaver. Now, there are other radicals too. So I could take something like y equals x to the power 1/3. Now I have to write it as 1/3 because I don't know how to get the 3 radical x notation to work on Desmos. But writing the exponent as a fraction is also fine. So if I wrote instead y equals x to the 1/2 power in green, why, that's exactly the formula here. So every power we can raise x to is going to have a radical function where the exponent on x is 1 divided by that number. So the cube root of x undoes the function y equals x cubed. There's our nice symmetry again. One thing you can see from this right away is that odd-numbered radicals are allowed to work on negative numbers, and they will give you a negative number back. Even-numbered radicals do not work on negative numbers, and they will never give you a negative number back. And that goes for any odd or even radical that you want to take. So I could take what is the 10th power root of x. The formula there is going to be y equals x to the power 1 divided by 10. This function undoes the formula y equals x to the 10th. Again, get this nice symmetry. But since 10 is an even number, the formula only works for 0. 0 is its own 10th root, and positive numbers. It does not work for negatives. If I bump this 10 up to something odd, let's make it 11, now that I've chosen an odd root that I'm taking, negative numbers are fair game. So, kind of like with the logarithm and the inverse trig functions, the arcsine, the arccosine, the arctangent, for right now, these are most useful to us in terms of solving algebra problems. But because they are all functions, they will also be fair game for when we start to think about things like continuity and slopes of functions that aren't lines. But for right now, I'm just trying to build up what's the encyclopedia of most of the functions that we care about, and for right now, this is our final entry. I will see you on Thursday night's lecture to talk a bit how we can use these functions together to create more interesting and strangely shaped functions. So I look forward to seeing you then.